Hello, this is Dr. Arberg, and I'd like to welcome you back to our course, Introduction to Reinforcement Learning Motion Control. The topic of our lesson is reinforcement learning, simulation, and animation. The mechanical system analysis tasks in reinforcement learning product development include specifications, system definition, system analysis, simulation validation, and implementation. In the specification, the analyst has to understand the needs as defined by the customer or by the company management. Also has to understand the mechatronic system which is intended for a solution, or perhaps it is a newly developed one. The system definition includes defining system variable parameters to represent design, performance, and the environment. Disturbances, including random and nonlinear, which reinforcement learning is very unique at taking care of and solving it. The system analysis includes kinematics with animations to validate that we meet the specified motion, and then dynamic analysis to simulate the motion under actuator force and reaction and disturbance load. The validation includes the dynamic analysis with exact solutions, mathematical solution, or lab testing, and also consulting with the system development team to make sure that the results make sense, and if not, to optimize the parameters such that each team member feels that it meets their needs, and the marketing folks feel that it solves the specification of the product. The implementation, once the simulation and animations are done, is being implemented into the reinforcement learning agent, which is going to be operated by the AI machine learning specialist. So let's take a quick look at some examples of product development, where we see here that the need is specified as a 6-10 lift for elderly. So a system concept that is newly being developed by Star Inc. Is shown over here. And over here, we see the definition of the parameters and variables like the mass, the length of the object which is being used. This is the system itself, and all the angles and the what you see here, the dimensions, the axes which are going to be used in the simulation. And over here is the specific definition of each one of the variables and the parameters like mass, gravity, relative angle, body force, etc. Over here, we see a portion of the system analysis where these are the equations of motion. It's in a matrix form where all the constants are over here in a matrix, and all the unknown variables like accelerations and forces and torques are on the other side. And these are equal to a certain disturbance forces or actuator forces, which are on the right-hand side of that equation, not shown here. And these matrices have to be solved using programming or TensorFlow. And the result is going to show actually up in the animation and the simulation and the reinforcement learning agent. This particular one is a MATLAB reinforcement optimization with an agent called TD3, and it shows the chair and the user being animated as homework assignment. You will have a chance to look at it, and it also shows the convergence of the neural network parameters which are being optimized by using the reward function as the critic and actual estimations of the total reward converge. That's pretty much when the simulation ends. And this happens over here close to 1,200 iterations. The next step is to prove the concept with some kind of a simple prototype. And then once this is validated and all changes are made in the design, then the final prototype can be used for testing with customers. The question that we like to ask in this course is how do we get a mechanical system analyst to join a reinforcement learning automation project? So the options are: one, to hire an experienced system analyst, PhD. And this is an estimated cost of $250,000 a year. They work for highly developed, very large companies, and hard to find. The other option, which we like to encourage, is to become one. And then if you are a mechanical engineer, you may consider the following options: education, hands-on experience, joining a company or startup. In education, you may obtain a higher degree, Master of Science or PhD, which take either 1 to 3 years, respectively, in universities at colleges that present this type of curriculum. The other option is to do self-study by online courses and related textbooks. And also very interesting option, like I've done when I got started with reinforcement learning, is to study some reinforcement learning tutorials by MATLAB, excellent ones by Amazon, by Microsoft, IBM, and Google. You can also test Deep Racer, very interesting and exciting, and try to model it. There are international concepts which Amazon shares with the Deep Racer. The other option is to build a simple mechatronic system with reinforcement learning motion control. And another option is to apply to a company for an engineering job where you may get involved with development of autonomous systems, such as SAR. And once you join a company like this, you would like to join the product development of a reinforcement learning product as a mechanical engineer and work closely with the system analyst. And the final option is, of course, a startup company with a very, very simple differentiating reinforcement learning feature. And folks who have stated that they were successful in embedding reinforcement learning features in the product said that they were very simple to start with. Not the complete product is doing reinforcement learning, just a specific task, like SpaceX is doing the landing with reinforcement learning. With that, I'd like to thank you for listening, and I look forward to talk to you in our next lesson.